So today is our last day for simplifying, or at least for the lesson on that. So we're kind of mixing them all together today. So lots of things we got to be aware of. And the first one here, we have two things under the radical, so we know we can put them back underneath the radical together. You might notice that there is a perfect square in 24. You can start with that. I don't really care how you start. I'm going to start with just putting 4 and then under the radical 6 times 24. And I'm going to say that in there 6 times 6 times 4. So 6 times 6 makes 6 squared, so I'm going to take out perfect square there. I'm going to take out a 6, and then the square root of 4 I'm going to take out perfect square. And so all I need to do is multiply all this together. 24 times 2 is 48. So that one we don't even have any radical in the denominator. Now, are there other ways to do it? Yes, you could notice the 4 first and take that out. So it doesn't really matter, just so you do a step at a time. This one, I think we already did one like this, maybe this exact problem before, I think. So what does 75 break down into? Perfect square would be 25 times 3. M to the 5th would break down to n to the 4th times m, and then n to the 2nd. So we get 5, which is square root of 25. Square root of n to the 4th is m to the 2nd. Square root of n to the 2nd is n, times the square root of 3m. And we would be done. If you want absolute value, it could be around the n there, but again, I'm not making you put that. So not too difficult there. On this one, remember, we cannot have a radical in the denominator, and we can't really simplify that the way it is, so I'm going to break it down into the square root of 45 over the square root of 4m to the 5th. I am going to simplify, though, before I go any farther. So 45, remember, is 9 times 5, so square root of 9 times 5, and I do have perfect squares down here, 4 times m to the 2nd times m. So taking my square root of 9 is 3, so 3 times the square root of 5, 2m times the square root of m. So now to rationalize, I need to multiply by the square root of m over the square root of n, leaving me 3 times the square root of 5m all over 2m squared. And there's nothing to cancel. Now, can you do this differently? Yes, if you don't notice that there's any perfect squares here, you can multiply by square root of 4m to the 5th over the square root of 4m to the 5th to rationalize the denominator, but you probably will end up with some things then that you need to simplify. Just trying to make sure I got the right answers before I move on. Alright. Next one, I hope we have enough room for this one. Again, we have to rationalize the denominator, but we multiply by the conjugate. So what is the conjugate? It would be 4 minus the square root of 5 over 4 minus the square root of 5. So in the numerator, I'm not going to do anything except just write it out. 2 times the quantity 4 minus the square root of 5. Over the denominator, 4 squared is 16 minus the square root of 25, which would be 5, so that would give me an 11 down here. 2 and 11 don't cancel, so I'm going to go ahead and distribute in the numerator. 2 times 4 is 8. Minus 2 times the square root of 5, all over 11. Nothing will simplify with square root of 5, so I would be done. Next one, I want to multiply again by the conjugate, so 4 plus 2 times the square root of 3 over 4 plus 2 times the square root of 3. So in the numerator, I'm just going to leave 3 times the square root of 6 times the quantity 4 plus 2 times the square root of 3. In the denominator, 4 squared is 16 minus 2 squared is 4 times the square root of 9, which will end up being 3. 4 times 3 is 12. 16 minus 12 is 4. So the 4 will not cancel there, so I need to go ahead and distribute up here. So I'm going to get 12, 3 times 4 is 12, but I still have times the square root of 6. And then multiplying here, 3 times 2 is 6, times the square root of 18, all over 4. Well, if you do notice, I have a perfect square in 18, so I'm going to go ahead and simplify that. 12 times the square root of 6, plus 6 times the square root of 9 times 2, all over 4. That's going to equal 12 times the square root of 6. If I take the square root of 9 is 3, but I bring it out and I already got the 6 here, so I need to multiply 6 times that 3 to give me plus 18 times the square root of 2 all over 4. Now you should notice that 12 and 18 have something in common, so I'm going to factor that 6 out that they have in common, so it's going to leave me 6 times the square root, whoops, not right, 6 times the quantity, 2 times the square root of 6, plus 3 times the square root of 2, all over 4. And now I can do some canceling here. So I'm dividing this by 2 and dividing this by 2, giving me my 3. And now I'm going to go back and distribute that. And I guess I'll write my answer up here. So let's come back up here and write the answer. So it'll be 6 times the square root of 6. I have to take my 3 times my 3 plus 9 times the square root of 2 all over 2. And that would be the final answer. So a lot of work to get that final answer.